Hello again. Here comes the video for our revisiting of section 7.2. Uh, remember, chapter 7 was it was law of cosines, law of sines, that sort of stuff. 7.2 had some application problems that we just didn't quite get to because we had another concept we needed to discuss yet. Um, so, for 7.2, we talked previously about bearing, all right, where we oh sorry hang on where we had north, south, east, and west, and we described directions things were moving by saying things like north 40 degrees west or south 72 degrees east, things like that. Heading, which is just a slightly different way of describing those things, uses measurements from 0 all the way to 360 degrees. So there's a few blanks to fill in the notes here. So number one, by heading, we're talking about sort of the direction an object is pointing or facing, where if there was no wind, no water movement, that's the direction it would go, as opposed to the true course of something, which is a vector. And we didn't talk about these things until now because we hadn't talked about vectors until now. So the heading of something is a vector that points in the direction they're going and how fast they would be moving without moving wind or water. The true course is the direction this object is actually moving and the speed it's actually going. And for flying objects in particular, like it says, we have a couple words here: airspeed and ground speed. Airspeed being a plane's heading, how fast it would go if the air was not moving at all, and what direction it would be going in, as opposed to ground speed. So we just have a bunch of examples here, and it involves sketching pictures of things, like always. And I'm going to do those sort of live, and then we'll go to the work. Once we have the picture dealt with, it's just going to be one of our classic triangle situations. And you'll have to use the law of sines or law of cosines or something like that to figure out some stuff. All right, so example number one. And I didn't even talk about how you measure bearing all that much. I'm just realizing that now, too. So with bearing, I'll just sketch that out first, and then we'll do this problem. All right, north is 0 degrees, straight up. So if something has a heading of 0 degrees, it means it's facing straight north. And then we just measure around clockwise to the direction something is pointing in for its heading. So rather than always angles less than 90 degrees and that sort of thing, we just take a plain old 0 to 360 degrees and use that to describe the direction something's going. So an object moving with a heading of 135 degrees would be going straight southeast and would have a heading, 135. You'd have 135 degrees right there. So a heading of 350 degrees, well, that would mean this direction, where the 350 is this measurement almost all the way around. So we know we'd have a little 10 degrees left in here. So we'll make a good use of properties between parallel lines or angle measures between parallels and adding and subtracting angles and lots of stuff like that. All right, so let's look at the picture here for this problem in particular. I'll get rid of all this. And there's a cat behind me. Wow, okay, we got a lot of stuff here. Okay. All right, most of it's gone. Okay. A boat is moving on a heading of 145. So, here's our boat. I'm going to put in our north line like we often do. 145 degrees is more or less this direction. 145 would appear right here. All right. And it goes 13.5 miles per hour. So there's the vector for the direction the boat is pointing and how fast it would go if the water wasn't moving. All right, but we're on the ocean, and the current is moving 2.1 miles an hour on a heading of 77. So the way we dealt with vectors before, this boat kind of has two forces on it. The force of the motor pushing it in the direction of 145 degrees, and the ocean current pushing it on a heading of 77 degrees. So we think of those two forces as vectors, and we have to add them up to figure out what the resulting force is on the boat. And the way we add up vectors, we'll draw the first one, we'll tack the second one onto the end of that one. So here's our first vector. Now we're going to tack the ocean speed onto the end of that. So from this spot, drawing a north line for measuring an angle, a heading of 77. So if you were pointing straight north and rotated clockwise 77 degrees, you'd get this kind of thing where 77 is right there. So the actual path of the boat then, connect beginning to end, comes from that line. So the question is, what's the boat's true course? So how long is that line, and what direction is it pointing in? All right, now we also have 2.1. So there's the speed due to the ocean current. So if you look at it, we have two sides of the triangle that are made here, and not quite any angles in the triangle, but we'll be able to get there. So now, like we've seen a lot, there's multiple ways to look at these things a lot of the time. So the first dashed line and the side 13.5, those two make this 145 degree angle. And this dashed line is parallel to the first one. So this angle is a nice alternate interior angle, which means we have 145 right there as well, which means in particular, right there inside the triangle, so to the left of the dashed line, but with that side, these two make a nice straight line, so 180 minus 45, that means we got 35 degrees inside there. So 77 and 35 together would give us the measure of that whole entire angle in the triangle. And if you look at what we've got then, we have a side, and we have two, or the one angle that those two sides make. This is side, angle, side. And so we got to think back to chapter 7, and okay, that's law of cosines, and we'll use that to find the length of the missing side, and then we can find some missing angles too. Now in terms of the direction this boat is actually going, 145 was this bottom side of the triangle. We need the top side. If we can figure out this little angle inside the triangle, we can just take 145 and back up however big that angle is. So from here on out, it is a side angle side law of cosines kind of problem. And rather than writing out all of that stuff, I'm just going to go to the one where that's all filled in, actually. And you'll see a lot of the same stuff I just drew here. So the 145 leads to 145 down here. So this theta that I labeled is 35. So angle B in the triangle, open up wide like that, is 112. So if this side is B, we do a little law of cosines to figure out how long that is. And we get 207.9. Oh, well, we get, after we take the square root, we get our speed, 14.4 miles per hour. And now that we have all three sides, we can figure out what that skinny angle is, what angle A is. And we do a little law of sines to figure out that, like we've done before. And we get 7.8. Now that's just the angle in the triangle. So to get that actual direction here, we're trying to get this angle. We got to take 145 and subtract angle A. And I totally wrote that wrong in the notes I'm seeing now. We need to do 145 minus 7.8, so ignore that. So what do we got here? 137.2 degrees. That's the correct answer. All right, got to fix that up. Okay. So that's one problem involving heading. Going to the next page, same kind of deal. We got a plane this time, though. So plane flies on a heading of 62 degrees, so it points in the direction of 62 degrees. The wind blows, we're not told how hard, due south, we do know that. So that, even though it's not stated with an angle measure, that's a heading, that's a direction. So the plane actually moves in that direction, 71 degrees. So find the ground speed of the plane. So how fast is the plane actually going relative to the ground, and how fast is the wind blowing? All right. I'm going to put a link to a YouTube video. Link to this one, but to a different video of planes landing into a crosswind. There's a couple nice ones on YouTube where you can really see a plane pointing in one direction while flying in another direction. When a plane is landing and the wind is blowing straight across the front of it, like perpendicular to the runway, the plane has to actually point in a different direction than the runway and try to land and straighten out right at the last moment. Anyway, interesting stuff. So for this problem, we'll get the picture and then we'll see the work on the other page. Plane is flying on a heading of 62. Okay, so nice north line, 62 degrees, right around in there. So remember, face north, rotate clockwise until you're facing that direction. The wind blows due south, so we'll tack the wind vector onto the end of the plane vector. And the resulting direction is 71 degrees. So this angle is 62. Oops. This angle, all the way to the bottom side of the triangle, that's 71 degrees. So this is 250, and this we don't know, and that is not where 250 goes. 250 goes up here. All right. So we got to turn these measurements into some angles in the triangle, and then we'll be able to use our triangle solving methods to figure out some things. So when we want ground speed, that means we want the length of this side, and speed of the wind means we need the length of that side, the one that represents the wind vector. Okay, so now this line points straight south, so if I were to put a dash line here, that would be one nice continuous straight line, and now we've got lovely parallels to deal with again. So the 62 here is actually an alternate interior angle with this guy in the triangle. So this one is also 62 degrees. And knowing the 71 and the 62, the little skinny guy in the triangle right here, you can just do 71 minus 62 and you'll have 9. And actually, then you've got 2 of the 3 angles in the triangle, so you'll get the third one just like that. And basically, we're in a, well, even before we figure out the third angle, we have 2 angles and a side, and that's the first triangle case that we looked at. So, just going back here, here's that similar sort of picture. Angle A is 9, like we said. Angle B is 62 by parallels and alternate interior angles. So angle C, the third angle, we can figure out. And after that, just figuring out side lengths is the law of sines like we've done so many times before. So little a, the wind speed, and then little b, the actual speed or the speed relative to the ground for our plane. And that's how it goes. All right, one more that I'm just going to straight up do. All right, and then there's, if we were in class, I'd have you guys work on those group exercises. I think it'd be, well, we'll get to that when we get there. All right, airspeed of 340 and headed due north. All right, so here's our plane, and I don't know how I did that. And here it is pointing straight north, so 340 miles an hour. The wind blows at 50 miles an hour. Wind blows at 50 and makes the plane's true course 352. So 0 is straight north. 360 would be the same as straight north. 352 then means we wrap all the way around and come up 8 degrees short. So this is 352 degrees. And that's the direction the plane is actually going. So there's some wind blowing to the left-ish, not necessarily directly west, which makes the sort of veers the plane off course and makes it go in that direction, in this direction instead. So the 340 is this side, not the left side. And that's just not going to help. Okay. So, well, what do we got here then? Oh, the wind blows at 50 miles an hour. So we do know a side length. And since this is 352, like we talked about, this is going to be 8 degrees inside there. And so if you look at what we have, a side, and not the angle between them, but one of the other angles, this is SSA, which of course is that last situation we looked at, the one that could have no solution or two solutions, that sort of thing. And if you kind of think about it, if a plane is facing north, but then ends up going in the direction 352, the wind could kind of be blowing with the plane and making the direction 352, or the wind could kind of be blowing against the plane and make the plane go in the same direction. Now, one case speeds the plane up and one slows the plane down, but either of those could deflect the direction of the plane so that it's going in that same direction, no matter what case you're talking about. So we're probably looking at a two-solution situation. All right, and basically we've got it already. We have our two side lengths. We got an angle measure in the triangle, so it's just a matter of going about this with side-side angle. So if we go look at how that turns out, there's that same picture, side-side angle. So like we do, we've got matching angle C with side C. And then we have another side, so we can use the law signs to find angle B. So you work through the law signs, your calculator tells you 71.2 degrees, which basically means we have two possibilities. So here it is. If angle B was 71.2, then we get the corresponding things for angle A, and then finally the law of sines gets us the possible side length for side A right there. And that's 353. And that picture is sort of the speeded up picture. All right, here's the direction the plane is going. The wind is kind of blowing with it and actually making it go faster than it was initially. So case 1 is this for B. The other one would be 180 minus 71.2 degrees. And that's what we see in case 2. So 108.8 leads to this angle for angle A, and law of sines leads to 321 for side A. And this is the situation where the wind is blowing and slowing the plane down, but deflecting it to go in that direction of 352. And you can see the angles kind of even make sense in the picture. All right. So what's left are a couple group exercises or things that you should just try yourself. So I think it makes tons of sense for you to pause the video and go through and see if you can do these two exercises. All right, I will, like, if you pause, I will actually go through and at least put together the picture, and we'll look back at the filled in version to see the work. But go ahead and give it a try and see how it goes. All right, assuming you paused and did all that, I'm now going to actually go through it. We'll see what this looks like. My leg fell asleep. Oh, yeah. Okay, sorry. All right, jet, London to New York, cruising airspeed of 515. Its heading is 255. So, measured from directly north, now 90 would be east, 180 would be south, 270 would be straight west. So we are talking kind of like this, and this angle is 255 degrees. All right, so now we're going to tack the wind onto this thing. The jet is flying in the jet stream, which moves in the direction of 213. So the wind is being tacked onto the end. We need to measure that angle from where the wind vector starts. And 213, well, again, 180 straight down, 270 straight west. So 213 is kind of like down here. Now we have 515 for the plane's speed. If the air was not moving at all, the plane would be going that fast. Here is this 213 degrees and 105 miles an hour, which might sound crazy, but that jet stream can actually do some wild stuff over the ocean. Just recently, a plane set the record for fastest flight London to New York because it was at its cruising speed and the jet stream was right with it and going blazing fast. And so anyway, new minimum record. All right, find the true course, which means beginning to the end, find the direction and the length of that guy. Now, we have two sides of the triangle, so we need an angle. And these angles that we have labeled are going to end up helping us figure some things out. So, I kind of redraw a little bit of this. So here we have that, here's that side of 105, and this angle here. If we continue this down, so this is 213 if you were to go all the way around, which means this right in here, well, straight south is 180. So 213 minus 180, we have 33 degrees right there. Now, 255, if we go all the way around, it's 360, which means right in here, that would be the rest of the way. So 360 minus 255, so we get 105 right there. And if you look closely at it, so here's that other dashed line, the 105 is right here, and that's an alternate interior angle with this guy. So this is also 105, however that happened. All right. So basically, inside the triangle, we get 105 degrees plus 33 degrees. So inside the triangle there, 138 degrees. And if you look at it, side, angle, side. SAS case. Kind of like the first example we did. So, law of cosines to find that side length to give us the actual speed. And if we can figure out this angle in the triangle, then we can, well, 255 gives us the top side direction. Subtract whatever that is, and we'll have the bottom side direction. All right, but at this point, we have two sides and an angle in the triangle. So this ends up looking like when we actually do the work. Oh, and I figured out our angles a little differently, and I got a different result for, oh, no. Oh, here it is, 138. Yep, angle C in the triangle is 138. Another property, so if you sort of picture whatever this angle is, and we had 105, this isn't the same as that angle, but these, because they're on the same side of this line, this one's the alternate interior angle with 105. This one plus 105, they have to add up to 180. So if this is 105, that means this guy here is 75. And so in the triangle, well, 213 all the way around, if we subtract that 75, we get what's left, and that's what happened here for 138. All right, the rest is what I said before. Side, well, law of cosines to find the missing side. 597 is what that works out to. And if we do the law of sines, we get little skinny angle A in the triangle. And that's this. So subtract and we get our direction. And here's the summary of that whole entire answer, or whole entire problem. All right, one more. Pause and do it if you haven't yet. Oh, on the next page even. All right, I'm going to start going through it. Pause and go work on it if you want to do it yourself first. Small plane heading due south. Okay, heading due south, 195. The wind blows at 35 miles an hour toward the east, but not necessarily due east. 35 miles an hour. So we don't know that it's making a right angle. It's just to the right somehow, 35 miles an hour. And makes the plane's ground speed 174. All right, so here's airspeed. All right, how fast the plane would be going if there was no wind, 195. The wind blows to the right-ish. and actually makes the plane speed 174. So what's the plane's true course? Well, part of it is we know how fast it's going, 174. All we need to know is what direction it's going, which basically just means figuring out that angle in the triangle, and we know all three sides. This is side, side, side all the way. Now, ultimately, we'll phrase the answer as a heading, though. So if the wind was blowing, or if the plane was going straight south, that's 180 degrees. The actual heading, so this is the actual direction of the plane, that's this measurement right there. And so if we can figure out this skinny angle, we can subtract from 180, and we will have the actual heading for the plane. Now, a little bonus question, what direction is the wind blowing? Well, so the wind is blowing that direction, in the direction of this vector, which really just boils down to, well, since this side goes straight up and down, just figuring out this angle in the triangle. So this doesn't always happen, but in this case, the angle in the triangle is actually the heading, the direction the wind is blowing. All right, and the results are... All right, there's our picture again, side, side, side. If you remember how side, side, side starts, that is the law of cosines, where we got to find an angle. And law of cosines always gives you the right answer when you use inverse cosine on your calculator. So we're going to find angle A. That's the one that's going to give us our direction. So we put A at the end and matching side A on the other end. And if we work that through, 8.7 degrees. So that's this little bit. This is the actual heading measurement that we need from straight north around to that direction. So subtract that, and here's our actual heading. And our bonus wind question means just finding angle B. And I think we can pretty much know, since the plane is slowing down, that this angle is less than 90. So when we use the law of sines, we get the actual correct answer. And it looks like the wind is blowing in the direction 48.9 degrees. So here's straight north. Here's that wind. 48.9 degrees is that direction. All right, that's it for our revisit of 7.2. I hope everybody's doing okay with all this weirdness that's going on. Shoot me questions if you've got them. Keep up with emails that show up, etc. And that is the end. Once I figure out pizza. Holy cow. Okay.